I was asked a question how to know the top half of the beam shown on the screen, is it under tension, and how the bottom half is under compression. So let's see if we have, here is the beam, and here is just a reminder, if I told you the positive axis system for X, Y, and Z, and here are the positive, and here is the positive direction for the moment. For example, if it's around the x-axis, which we called back then during the lecture, we said the thumb rule. So you just have to make your thumb in this direction, and that's how you know this is the positive direction for 4M. So let's see, for example, here we wanted to decide on an axis system. So let's decide, for example, here, just 1 second to draw a line. Here it is. So let's, for example, assume this will be the x-axis for my system. So it will be along the cross section, and here is my y-axis, and of course along the longitudinal direction of the beam I will have my z-axis system. So as you can see, it has to agree with one of these three systems shown in this figure. Alright, so if I agree on such system and assume now, for example, I have bending moment here calculated and it goes in this direction m. Alright, and now you were asked to apply the rule, which is sigma equals to my over I xx. Alright, in this case I was asked, how do I know the top half is in compression or in tension? Alright, first of all, the m shown in figure, this one, is it positive m or negative m? If I look at the thumb rule and I put my thumb in the x direction, alright, which means in this case we'll be going inside the screen, alright, here is y, so zx will be going to the inside to the screen. If I look at this m, I will find simply that m in this case, m is negative. So actually it is minus m. Alright, because it's not doing in the positive thumb rule. If you do in the positive thumb rule, put your thumb in the x direction, it check m. Actually the m, if it's positive in the x direction, mx should be clockwise, but it's not clockwise. Alright, again, according to the system of axes I choose. Alright, so in this case m is negative. So if you want to find the stress in the top half of the beam, so I will substitute in the equation minus my over I xx, it will come, as you can see, negative. Alright, it's not positive, which means it's compression. Alright, so the equations tell you it's compression according to the system of axes and the positive thumb rule we agreed on. Also, you can notice here, if you look at the direction of mx, it's going in that direction. So you can imagine immediately that it will be stressing the stress will be going in this direction, alright? Because m is going this way, which means the stress will be going this way, right? And if it's going that way, means the stress here will be going this way. So now also you can understand this will be in compression and the bottom half will be in tension.